All right, here we're going to use the distance formula and the slope formula to prove some geometric facts about some shapes on the coordinate plane. In this example, we're going to use the distance formula and the slope formula to determine if the polygon with the vertices -4, -2, B, 0, 4, C, 3, 2, and D, -1, -4, forms a rectangle. So we're going to talk about some of the things that are required for a rectangle. First off, we know that opposite sides have to be parallel. So line segment AB has to be parallel to line segment AC, and line segment AD would have to be parallel to line segment BC. Okay, we know from parallel lines that the slope would have to be the same. So if we just look at the slope of line segment AB and line segment CD, or DC, as the case may be, let's just find the slope of each of those segments. So the slope of line segment AB would be M equals y2 subtract y1 over x2 subtract x1. This is our slope formula, and for line segments A and B, the y2 would be 4, y1 -2, x2 0, x1 -4. So we have 4 minus -2, which is 6, and we have 0 minus -4, which is 4, and 6/4 reduces to 3/2. Taking a look at the slope for line segment CD to see if it's parallel to AB, using the same formula, y2 subtract y1, our y2 -4 minus y1 2 over x2 -1 minus x1, and here we have -4 minus 2, -6, -1 minus 3, -4, and this reduces, negative divided by negative gives us a positive, and 6/4 reduces to 3/2. So we know that the slope of line segment AB is congruent or equal to the slope of line segment CD. All right, we know those two lines are parallel now because they have the same slope. So line segment AB is parallel to line segment CD. Now, in order for this to be a rectangle, two more things have to be true. They have to be of equal length on opposite sides. So line segment AB and line segment CD would have to be the same length. We can prove that using the distance formula, and the distance would equal the square root of, in parentheses, x2 minus x1 all squared, plus, in parentheses, y2 minus y1 all squared. You might notice here that we have the exact same values, because we are going to have y2 minus y1 and x2 minus x1 in both the slope formula and the distance formula. So once you get used to doing this, you can actually reuse some of the values, but we're for the sake of clarity here, we're going to plug in the values again. x2 minus x1, this is going to be the distance from line segment AB. And x2, 0 minus negative 4. That's x2 minus x1. And y2 minus y1, 4 minus negative 2. And all of that squared. And here we have 0 minus negative 4 is 4. And 4 minus negative 2 is 6. So we have the square root of 16 plus 36, which is 52. So the distance for line segment AB, or the length of line segment AB, using the distance formula, is the square root of 52 units. The distance for line segment CD. Using the distance formula, just as it's written up there, this time our x2 minus x1 would be the x coordinates from D and C. So x2 would be negative 1, x1 would be three, all of that squared, plus y2 would be negative 4, minus y1, which is 2, all squared. We now find we have the square root of negative 1 minus 3 is negative 4, plus negative 4 minus 2, which is negative 6. Notice I'm leaving these values in the parentheses. If you don't put these parentheses around your negative numbers, if you type into your calculator negative 4 squared without the parentheses, the calculator is going to find the 4 squared first. It's going to do the order of operations and do the exponent before it makes it negative. The multiplying by negative 1 is how you make something negative. So it's going to do that multiplication after it does the exponents, following the order of operations. So if we put these parentheses around it, it makes sure that we are multiplying negative 4 times negative 4 when we do negative 4 squared. And that becomes important because you can't have negative values under the square root and get a real number. So negative 4 squared is positive 16. Negative 6 squared is positive 36. And the length of line segment CD is also going to be the square root of 52 units long. So that we now know that these two sides are the same length, and we also know that they are parallel. Okay, well, this still could be a parallelogram. What else do we have to know in order to form a rectangle? Well, we have to know that the angles that are formed are right angles. Now at this point, it doesn't matter which ones we choose, and we also are going to need to know that line segment BC and line segment AD are parallel. If they're parallel and one of them's perpendicular to the other two line segments, the other one obviously is going to be perpendicular as well, because they will have the same relationship to the other parallel lines. So let's go ahead and check to make sure line segment BC is parallel by checking the slope. And we're going to have to find the slope for another reason, but line segment BC, the slope of line segment BC will equal, again, our slope formula, y sub 2 subtract y sub 1 all over x sub 2 subtract x sub 1. And looking at our coordinates, negative 2 minus 4, y sub 2 minus y sub 1 over 3 minus 0. And our slope here is that was not negative 2, I'm sorry, that was positive 2. That was positive 2 minus 4. And 2 minus 4 is negative 2, and 3 minus 0 is 3. So our slope of line segment BC is negative 2/3. Just to make sure the other is parallel, let's take a look at the slope of line segment AD. y2 minus y1 all over x2 minus x1. And we find that negative 4 minus negative 2 all over negative 1 minus negative 4. Well, negative 4 plus 2 is negative 2, and negative 1 plus 4 is positive 3, and the slope of line segment AD is 2/3. So since the two slopes are equal, we know that line segment BC is parallel to line segment AD. So we've just proven our parallelism of opposite sides. We're in great shape there. Now the only thing we have remaining to do to prove that this is a rectangle is to prove that these are 90-degree angles. Well, this requires us to remember some of our algebra with linear equations. And what do we know about the relationship of slope of perpendicular lines? All right, there are several ways to say this. I think the easiest way to say it, it's the opposite reciprocal of one another. So if two lines are perpendicular, so if the slope of one line is A over B, then the perpendicular line, then the slope of a perpendicular line would equal negative B over A. My students often like to remember this as flip it and change the sign, but it's the opposite reciprocal or the additive inverse of the multiplicative inverse. So let's take a look at our slopes. We have 3/2 and negative 2/3. The opposite reciprocal, so these lines are indeed perpendicular, so they do form 90-degree angles, and therefore polygon ABCD is a rectangle. because all angles are 90 degrees. Or right angles, and opposite sides are parallel.